All right, so we are going to look at a review of lessons 1 through 3 of our expressions unit, starting off with lesson 1, which is parts of an expression. So first thing we're looking at here is how many terms are in the polynomial. So those are things that are split up by the plus or minus signs. So we've got 9a, we've got negative 10b, and we've got c. So there are 1, 2, 3 terms here. Then actually listing those out, we have to include those positive and negative values. So this 9a is positive. We have the 10b has the subtraction in front of that, so that's negative 10b. And positive c, so I'm just writing that as c. With our like terms, we are just pointing out those that are alike. What do they have in common? So we've got 9a, there's nothing else with an a, so there's no like terms there. We've got the negative 10b, but nothing else has b, so there's no like terms with that. And then we have c, and there's nothing else with c. So there are none. There are no like terms. Next, I'm looking at the coefficients. So this is where I like to highlight. So I'm picking a color and I'm going to highlight anything that has a variable in it to know that that should have a coefficient. So 9a, actually, let me actually highlight that. 9a should have a coefficient because there's a variable. Negative 10b should have a coefficient because there's a variable. And c should have a coefficient. So now I'm actually listing that out. We're talking about the numerical value of the terms. The numerical value of 9a is 9. There's 9 a's. The numerical value of negative 10b is negative 10. And then being careful, don't write c. That is incorrect. The numerical part, even though there's not a number there, is 1 because there's 1 c. And then I would highlight my constants in a different color. That's anything that's just a number, but there's nothing here that is just a number, so there are none. All right, let's look at number 2. How many terms do we have? We've got 1, 2, 3, 4 terms here. Now let's look at what those actual terms are. Remember, you have to include the plus or minus. So we've got positive 3x. We've got negative 7. We've got negative 15. And we have negative x. The other way to kind of remember it is that I'm essentially just putting a comma in between everything. 3x, comma, negative 7, comma, negative 15, comma, negative x. Like terms. So this is when we're looking at what is alike. So we've got 3x. Anything else that has an x in it? Yep, over here we have a negative x. So 3x and negative x are like terms. We also have constants, which are just the numbers, are like terms as well. So negative 7 and negative 15 are also a pair of like terms because they can be combined. Coefficients, I'm going to stick with my same color that I was using before to highlight. So I'm going to highlight my coefficients in green. So anything that has a variable in it. So this term has a variable. Negative 7, negative 15 doesn't, but negative x does. Since I have 2 terms with variables, there should be 2 coefficients. The coefficient of 3x is 3 because there are 3 x's. The coefficient of negative x is negative 1. Just negative 1, not x in there. So there were 2 terms with variables, there's 2 coefficients. Then with a different color choice, I'm going to use yellow. I'm going to highlight my constants. Those are the ones terms without variables. So -7 doesn't have a variable. -15 doesn't have a variable. And we write those as is. -7, -15. All right, let's try the next one. Number 3. How many terms do we have? We've got 1, 2, 3, 4 terms. I make that look a little nicer. -4. Now, what are those actual terms, including our positives and negatives? We've got -16m. We've got positive n. We've got -8m. We've got -5n. Again, it's basically everything just split up and putting commas in between. Let's look at our like terms. We've got a -16m. Does anything else have an m in it? Yeah, the 8m, but again, it's a -8m. So -16m and -8m. I see I've got n, but nothing, or actually, sorry, I have an n here and I have a -5n. So that is also a pair of like terms. Now I'm looking for my coefficient, so I'm going to highlight, keeping with the same color. My coefficients are the terms, or with the terms that have variables in it. So this has a variable, this has a variable, this has a variable, and this has a variable. Since I have 4 terms with variables, there should be 4 coefficients. My numerical value here is -16. My numerical value of n is 1n. My numerical value of -8m is -8. And my numerical value of -5n is -5. And then my constants, I would highlight in another color. That's all the terms that do not have a variable in it. They're just numbers. There is nothing that doesn't have a variable in it. So the constants, there are none. All right, one more for parts of an expression, and then we'll move on. How many terms do we have in this? Well, I'm going to count them out. We've got 1, 2, 3, 4, 5, 6 terms. The actual terms, again, I can basically put commas between them all. So we've got 4x. We've got positive 2y. We've got -x. We've got -3. We've got -5y. And we've got positive 12. Our like terms, ones that share a variable. I've got 4x. Does anything else have an x in it? Yeah, -x. So one pair of like terms is 4x and -x. I've got positive 2y. Does anything else have a y in it? Yep, right here. We've got -5y. So positive 2y and -5y. And then our constants, just the numbers, we've got -3 and positive 12. When they're just numbers, they are also like terms. So -3, positive 12. Our coefficients, again, I'm going to highlight in the same color I've been doing any term that has a variable in it. 4x has a variable, positive 2y has a variable, -x has a variable, -3 does not, -5y has a variable, 12 does not. So the numerical part of these terms, there's 4 of these terms, there should be 4 coefficients. The numerical part here is 4. The numerical part here is 2. Here, -x is -1 and -5. And then last but not least, I'm going to highlight my constants, which are the terms that don't have variables. They're just numbers. So we've got -3 and we've got +12. That's it for the review of parts of an expression. Now, let's look at evaluating expressions. So when we are evaluating, we are plugging in these values and we want to be really careful with all of the negatives. That's what's going to throw people off. So we are plugging in if x is -8. So that is being plugged in where x is. And we are plugging in if y is -7 to where our y value is. So I'm just going to put parentheses around where we need to plug things in. Minus. Okay. I'm plugging in my y value was -7. And I'm plugging in my x value was -8. Okay. Order of operations here. The first thing that I should be doing is my exponents before I do any of this subtraction. So we're doing -8 squared. -8 times -8 is +64. Then I'm bringing everything else down. Minus -7 minus 64. A lot of people want to combine this minus with the x right away, but that technically is subtraction or multiplication. You could see it as we need to do this exponent first. Now, I'm going to simplify further. When I see minus a negative, I know that the opposite of a negative is a positive. So we have +7 minus 64. Now we are just using our integer rules, okay? We've got a positive and a negative. So we are finding the difference, which is 57. There were 7 positives and 64 negatives, so there were more negatives. So our answer is -57. Let's do another one. Being extra careful with how we're plugging them in. So I'm going to rewrite with parentheses wherever our x or y is. We've got negative. We're going to plug in an x value minus negative, plugging in a y value. So I'm plugging in my x value is -8. My y value is -7. Okay. So within these parentheses, I'm going to do that first. So I'm first going to figure out what is the opposite of -7. Well, the opposite of -7 is +7. So I'm rewriting everything. Negative, our x value of -8 minus 7. Let's simplify again. We've got this minus -8. Whenever we see minus a negative, that really means a positive. The opposite of a negative is a positive. So we have +8 minus 7 equals 1. So our final answer is 1. Let's do 2 more before moving on to our last thing, which is writing expressions. So we've got z minus, and then in parentheses, x plus y. Let's write in. We're going to have to put z somewhere minus our x value plus our y value. So I'm going to plug in my z value here is -22. My x value, which is going right here, is -10. And our y value, which is right here, is 5 being plugged in here. looks like this. If you don't want to put the extra parentheses where you're plugging in for this one, that's fine. But again, be careful what you're plugging in. So I'm going to rewrite it the other way. Let's say I didn't do all those parentheses and I just plugged in. We've got negative 22 minus plugging in my x value of negative 10 plus our y value of 5. That works too. I'm going to simplify within my parentheses first because that's what the order of operations says to do. So we've got negative 10 plus positive 5. Those are opposites. We find the difference, which is 5. There were more negatives, so it is negative 5. So we have negative 22 minus negative 5. Anytime I see minus a negative, that means plus a positive. So we've got negative 22 and positive 5, which are opposites. So we find the difference, which is 17. There were 22 negatives, 5 positives. So there's more negatives than positives. And last one, this one tends to be tricky. So we want to be really careful as we are plugging this in. So first off, it is negative. We are plugging in an x value, squaring it over our y value. When I plug in my x value, we had negative 10. When I plug in my y value, we had 5. Here is what is important to note. When we have negative x squared, this technically means negative 1x squared, which is multiplication. If we have multiplication and exponents, you have to do the exponents first. So when I'm doing the order of operations here, I am first doing the exponents, negative 10 squared, then I will apply this negative. So negative 10 squared, negative 10 times negative 10 is positive 100. Then I apply this negative after the fact. So it's negative 100 over 5. A positive divided or negative divided by a positive is a negative. 100 divided by 5 is 20. All right. Last part, we are looking at writing expressions. So 9 times the sum of a number and 3. I'm going to circle my numerical values. We have 9. We have 3. I'm going to underline my unknown, so a number. I'm going to say n equals a number. And then highlighting my keywords. Times tells me multiplication, sum tells me addition. So my two operations are multiplication and addition. So we are doing 9 times the sum. So 9 times, in parentheses, the sum of our unknown number and 3. Number 10, the difference of a number and 12. So the numerical value that I see is 12. Our unknown still is a number, so n equals a number. And then our keyword that tells us the operation is difference. Difference tells us subtraction. So the difference of a number and 12, we are just going in that order, n minus 12. All right, one more. The length is 5 less than 4 times the width. So first, circling my value, my numerical values, we've got 5, we've got 4. Our unknown, well, we technically don't know the length or the width, but we are relating the length to the width. So I'm using the width as my numeric or my variable. So I'm going to say W equals the width. And then our key phrases or words that tells us the operation, less than and times. Less than tells me subtraction, times tells me multiplication. What's important to note is anytime we see less than, it's the opposite. 5 less than means we are subtracting 5 from something, What are we subtracting it from? 4 times the width. So 4W. And that's it.